So one other thing I should mention here when we're talking about the setup for parabolas is an idea that's sort of analogous to the center from when we were talking about ellipses and hyperbolas. That is a single point here that we can try and build our shape around, where in this case we don't have that idea of a central location based on the shape of the parabola, at least not in the same way. Instead, we talk about an idea called a vertex, where the vertex, if you think about that sort of bend in a parabola, can be thought of as the point at the bottom of that curve, where that position at the bottom is an important one for calculus that you will see fairly early on if you ever learn about derivatives. But for us, in this context, we can think of that that center of the parabola as being the point where we have the minimum distance from our parabola, from the set of all points we're considering, to the directrix and the focus. That is, it's the point along the parabola where the directrix and focus are closest. And in the same way that we talked about things being centered at the origin, in this context we'll start by looking at parabolas where our vertex is at the origin, where in the first case we have the general form y squared equals 4px, which is the case that we have where our parabola opens in some sense horizontally, and because we are opening horizontally, our directrix is a vertical line, where that value p tells us something about the position relative to the directrix and focus, where we have that the directrix is going to have form x equals negative p, it's a vertical line, and the focus will be at a point of form p0. It's going to be some coordinate along the x-axis at position p, depending on whatever that value is. And then on the other hand, we have for the vertical arrangement, that is where the parabola opens upward or downward, which is probably what you're more familiar with, probably what you're more used to, we have the general form x squared equals 4py, where here, when we look at the focus and the directrix, the focus is going to be at a point of form 0p, and the directrix will be a horizontal line now with form y equals negative p. And these patterns here are a bit abstract as they are. You've seen these before though, and the easiest way to really understand what we're looking at here is to get another basic example. So for this example, we want to find the parabola with focus at 8, 0 and directrix at x equals negative 8, and then sketch a quick graph of it. So in this case, based on how our focus and directrix are given, they're both given in terms of x values in some sense. We know that they're both going to be occurring along the horizontal axis, and as a result, our parabola is going to be opening sideways. So we have form, let's get this right here, I think, y squared equals 4px, where based on the fact that our focus is at the point 8, 0, that tells us that p is equal to 8. And as a result, we have the general form y squared equals 32x. And if we want to graph that y squared equals 32x, we have our directrix like so, our focus inside of it like so, and then that opening curve coming in to the, let's see, if we're facing our direction, it would be my left, so that'd be your right, to be sure. But remember, when we're making these shapes, we always have that the directrix is in a sense outside of the parabola, because the directrix never actually hits the parabola, and the focus is always on the inside of the curve, as it were. And from here, it's nice to think about these things in their prettiest and most straightforward form, but, well, it doesn't always happen this way. So we're going to look at a more general standard form. We're going to talk about points that have the vertex not at the origin, a more general vertex at coordinate hk.